15.2, it says solving equations having like terms in parentheses and all that good stuff. We know how to do this. This is what we have been doing. Simplifying, then solving. Okay? Example number 1 says school spirit. Your school's basketball team is playing in the championship game. Hey, congratulations. Now, for the game, the cheerleaders want to buy a banner that costs $47. They also want to buy small items to give to students in the stands. Pom-poms cost $5.20 each. Noisemakers cost 80 cents each. The cheerleaders have a total budget of $375. Okay? If they buy equal numbers of pom-poms and noisemakers, find how many pom-poms and noisemakers the cheerleaders can afford to buy, and as described above. Let me ask you something. What are they asking us to find? What are we looking for? There's a number, but what does that number represent for us, Mo?
The number of pom-poms and noisemakers.
Now, what do we know about the number of pom-poms and noisemakers?
The price?
No, not the price. What do we know about the number that we buy?
That they're going to be the same.
They're the same. So do I need 2 different letters, Connor? If they represent the same number? I don't. So why don't I just let X equal what? What is X standing for? Sarah B?
Or no?
Hang on. Kate?
Pom-poms and noisemakers?
Well, not together, but it's the number of pom-poms or the number of noisemakers, right? The number of pom-poms or noisemakers. It's not the 2 of them together, but it's the same, isn't it? Okay. Well, we need to write an equation with this stuff, showing how much they spend. Who can tell me one amount that they spend? Hank? $5.20. $5.20. And that's for what? It's for all of them?
No,
Each. So how do I represent how much they spend on all of them? Not by how many people are in the stands. Claudia?
By the number of pom-poms or noisemakers.
By the number of pom-poms or noisemakers that you buy. And do we have anything that represents that amount, Claudia? X does. Okay, so that's how much we spend on pom-poms. Who can tell me another amount that we spend? Mac? $47 for the banner, right? Okay. Do we spend money on anything else? Devin?
Noisemakers.
How do we represent the amount of money that we spend on all the noisemakers?
80 cents.
Plus 80 cents. Man, this is cheap noisemakers. Is that right? Wait, what, Bolton? Oh, you mean I need to multiply this number by X, Devin? The number of noisemakers. It's not 80 cents for all of them.
Oh, no.
It's 80 cents for each one. Now, if I add up all those amounts, what should I get, Connor?
Well, actually, I have a better idea. Could you do
Well, wait, whoa. I'm not going to turn back on my trip now, right? But I know this amount has to be what, Maddie?
Less than or equal to
Less than
375.
or equal to 375. Maddie, I could not have said that better. Perfect. Now, we want to solve this thing. Let's treat it just like an equation, though. Even though I wrote that inequality sign, I do it the same way I would an equation. Okay? What do I need to do first if I'm going to solve it? Kate.
You combine like
Let's do combine like terms. This one and this one. When I put them together, what do I get, Kate? 6x, right? 6x plus 47 has to be less than or equal to 375. Joanna, what do you want to do now? Me too. Let's subtract 47 from both sides. Okay? And Truman, what do I have over here on this side?
6x.
6x is less than or equal to, what do I get on the right side? Raise your hand, Megan. Whoa, hang on, what? 375 minus 47 is what, Katia? 328. And then what do I do from there? Mo? Divide each side by 6, and x needs to be less than or equal to what? It has to be less than or equal to. That's Sean B.
375.
No. No. Remember, we had to divide both sides by 6. What did we get when we did that? Megan? 54.6 repeating. Now let me ask you something. Can I have 54.6 repeating pom-poms? No. Okay, so I need to round it, but wait, can I have 55 pom-poms?
No.
I don't have enough money for that much. How many? 54. I can have 54 pom-poms and 54 noisemakers. There we go. Nice. Now we're getting there. That was a good job. That's the hardest one we're doing today. That was a sticky one there. Let's look at the next one. Hang on, Connor. Do you mind if we go on? Thank you, sir. Example number 2 says solve the equation. What should I do first in A? William?
You should first see if there's anything you can combine, like 7 and 8.
You're wanting us to simplify. And what does it mean when you hear the word simplify? You automatically think, bing, volt, PEMDAS. So look at both sides of this equation. Are there any parentheses, stuff that I can do, or multiplication and division, addition, subtraction? What can I do to simplify before I solve? Maddie?
You could do distributive property.
Absolutely, Maddie. Excellent. So 7 times 3 gives me what, Maddie?
7 times 3 is 21.
And then what do I do next?
And then you do 7 times x.
It's not x, is it?
No, it's a number.
Well,
Negative x.
it's negative x. So what's 7 times negative x, Maddie?
7 negative x.
Not 7 negative x. No. Joanna? Negative 7x. Because remember, what's in front of the x, Maddie? A negative 1. And 7 times negative 1 is negative 7x. Okay, good. Now what do I do from there, T?
You add 21.
No, I don't want to add 21. Don't want to do that. I'm trying to get that x by itself. Sean B?
Yeah, you try to get x, negative 7x by itself.
I do. How can I do that?
You do
Minus 21 here, minus 21 there. And then Devin's going to tell me what I have left here remaining on the left side.
negative 42.
Negative 42. And what do I have remaining on the right side, Katia?
Negative 7.
Negative 7x. And what do I need to do next, Ashley?
You need to divide negative 7x by negative. You need to divide negative 7x by negative 7.
Okay, but this is algebra,
So whatever.
so I have to do it on the other side. What do I have remaining on the right side now, Hank?
You have 6.
On the right side, Hank, the other right. X. And then on over here remaining on the left side, 6. Beautiful. Nice job, Hank. Very good. Bolton, what do I do next on B over here? Absolutely, we want to simplify before we solve. So Bolton, what do I do first? And that gives me? Good. And then what do I do? I don't see 4x up there. Negative 4x. Okay, what do I get? Positive or negative? Positive 12x is equal to 12. Nice. Raise your hand if you want to tell me what I do now. Hank.
You're gonna want to get, put, you get rid of 24.
I don't.
You get rid of negative 24.
And how do I get rid of it?
Adding 24.
Add 24 to both sides to get rid of that. Good. And what do I have remaining on the left side, Hank?
12x.
12x. And on the right side?
36.
Good. Katia, what do I do next?
You have to divide 12 by 12. And then you do 1/7.
And so what do I have? Good job, Katia. Truman, what do I have on the left side? X. And on the right side, Maddie?
You have 3.
3. Awesome. Beautiful. Love it. Let's look at the next one. Joanna, what do I do first?
Wait, okay. First,
It says solve, and that means what?
variable
Yes, but before I do that, I need to. Exactly, and that means PEMDAS. So if I can do any multiplying, dividing, adding, subtracting, I'm going to do it, right? Do you see anything I can do?
5x
Yeah?
and negative 2 and is that negative?
Hang on, Joanna. What do I need to do to simplify this thing, please? Sarah B?
Distributed
Yep, distributed property. And what do I need to distribute, Sarah B? Negative 2 times what? X? And what do I get? Good. What else? And that gives me positive or negative. Okay. I just bring down the other stuff. Good. Now what do I do? Am I simplified yet? Mo?
You need to combine the like terms, which is 1 with the x.
Exactly. So let's put together the 5x and the negative 2x. What does that give me?
You get 3x.
3x plus 2 is equal to 8. Is there anything else I can simplify, Connor?
Yeah. Oh, no.
There's not? Okay, we're ready to solve. Tell me what to do, Connor.
Okay. Well, you need to get the variable by itself.
Yep.
First, you need to subtract 2 from 2.
And also from the other side.
So on
Left side?
you have 3x.
Right side?
You have 6.
Excellent. T, what do I do next?
You subtract 3.
No, I don't subtract 3 because I'm not undoing addition. Ashley?
You divide 6. You divide 3x by 3.
Uh-huh.
6 by
Exactly. I need to divide by 3 on both sides because I'm undoing that multiplication. What do I have remaining on the left side, Devin?
X.
And the right side, Truman? Beautiful. Nice. Okay. I'm not sure if we have enough time to do this last one. Let's just check. Whew. I don't think we can do that in a minute and 30 seconds. You want to try? Raise your hand. Tell me what to do. Quick. Mo.
Okay, first what you need to do is the distributive property.
Good. Negative 3 times y.
Negative 3y.
Excellent. And then negative 3 times 4.
Negative 12.
Negative 12. Bring down the 2y. It's equal to 13. What do I need to do next? Devin.
Subtract 2y and 3y.
2y and 3y are like terms. When I put them together, Devin, what do I get?
You get negative 5y.
No, I'm...
No. Oh, sorry.
Sean B.
Negative 1y.
Negative 1y or just negative y minus 12. What do I do next, Kate?
Combine negative y and negative 12.
Can't combine them. They're not like terms.
Oh, yeah.
Joanna,
We're at 12.
add 12 to both sides. That gives me 25 is equal to negative y. Mac? I don't want to know what negative y equals.
25 equals 1.
Okay, if this is negative and that's positive, we just change their signs. Y must equal negative 25. Nice job. I didn't think we could do it, y'all, and you did it. Great job. You're ready for your homework.